Hey guys, what's up? So in this video, we'll be discussing about file upload, and this file size can be anything, and we'll be uploading by the browser. And this is very normal scenario, right? In Facebook or Instagram or anywhere, right? We can upload the files, and these files it will show in the browser like 1%, 2%, and then ultimately it will go to the server, and from the server it will distribute to many other systems. So the entire flow will be doing the system design, low level, high level, and then we'll go to the code. We'll be showing how it works on the real time. So please stay connected till end of the video, and if you have anything, please share in the comments. If you have any system design, if you want to discuss with me, please put in the comments so that you can discuss in the next video. Thank you. Alright, so now in Facebook, right, so once we go and upload a video, we must have seen how it's uploading and what underneath it happens. So we don't know, and in this video let's try to explore how it works internally, right? And you just take your time and go through the question. It's very simple. Somebody will upload this file and how internally it works, how it makes sure that the file is not corrupted, how it ensures that it will reach to the destination. And there can be multiple data centers. Let's say we have Asia, we have America, let's say many we have all the continentals, right? So how it reaches to all the different DCDR servers. Now that is a problem statement. So you'll upload the file, and that file will be there in the storage, and from that storage it will go to multiple locations, as a DC or DR, basically data recovery, I mean. And then from there it will, from some place wherever the user is situated, from there they can browse the file. So that's the ultimately goal, right? So you can think about the system design and pause this video and come back with the solution. All right, I hope you have your solution ready. So this is my solution. That solution may vary from yours, but ultimately the ultimate goal is to upload the file, and you have to make sure the file is not corrupted, and you have to make sure that it will reach all the destinations, right? So starting with the browser, so there will be a client, right? And as I said, right, that file size can be anything, right? So in one shot we cannot send the file. So we have to split the file into multiple parts, and that splitting, what I have done, I'll be doing in the client side. So when I say client, it's basically on the browser. I'll be splitting the file, and from the browser there will be a REST endpoint. So I'll be doing the coding in the Spring Boot, but whoever from the Python or any other background, right? So there will be a API you have to write in that REST endpoint. What you have to do, you have to so each of the chunks, it will go to this API, and then we'll do the further processing. So first what we'll do, we'll make sure that all these chunks, it will go to the, let's say, any of the drive. It can be S3 or Google Drive or anything, right? I just assume that Google Drive. And then once everything is done, we'll make sure that in the Google Drive we'll merge the code, and whatever the hash key over here, right? So the client, it will generate a hash key, and that hash key I'll be basically compare with this file. So once we'll merge the file, so that is what I am doing, this if else condition, as you can see over here, right? So and then we have to send all these chunks to the different servers. So obviously we'll be using Kafka, right, for the distribution system. So this guy, at all the points, right, they should know what is my last file or last chunk. So that is what that if condition, and I have to push the message into the all the brokers, right? Now once this upload is done, right, so this is one validation. I just know I said, right, there is a hash value I have to generate. Now that hash has to match, right, whatever the hash I'm sending from the client, it has to match with the file it got generated after the merging. So you have to merge the file, because it doesn't make any sense to put the split files, right? Ultimately the goal is to put store over here, and then all the split files has to be sent over here. Now all the files will be sent, and then you have to make sure that if it is not corrupted, then you have to again merge the files over here in each of the continents. Let's say Asia, Europe, America, right? All the places you have to merge the files at all the consumers, and if it is corrupted, we have to delete those files ultimately, right? So you can have a different design for this, but this is the design which I thought. If you have any other design, please let me know in the comments, or you can in the comments you can attach your system design. All right, let me repeat once again. So I'll upload the content. This content can be of any size, right? And from the browser I'll split the file. Basically with the JavaScript I'll be splitting the file into multiple parts, and it will go to the endpoint, and in the endpoint somewhere the browser has to tell me which one is the last chunk. So as soon as I'll get to know what is the last chunk, I'll be keep on pushing the messages, and in the messages, maybe in the header, in the we have to send the message into the Kafka, right? So in the Kafka, basically maybe in the header or somewhere I have to tell, is this the last message? And then ultimately at the consumer end I'll be keep on merging those files. Now there is one more point. I just said what is the hash value, because I have to make sure that whatever the file I'm combining, right, it has to be the same hash. Otherwise, it is corrupted, right? So that is what I'll be doing from here. So the browser, originally whatever the file it got uploaded, it knows what is the hash value, right? And anything, if I change anything or any miscalculation happens over here, the hash value will be different, which makes sure or which ensures that my file is not corrupted, and it will come over here and it will send across all my consumers, and the consumers will take the decision. If the file is not corrupted, it will go ahead and merge all these files. If it is corrupted, then okay, it will not do anything. Again, it depends on the last chunk, right? And then it can do the decision like where he has to store. So in this case I'm just showing here in the Amazon S3, I'll be storing everything. Now in this case, one thing I didn't add is a database. I could have add one database over here, and it will know what is the location of the each files, right? And we can in future we can use that for our reference, but we can add it. All right, with this understanding, I hope you got the system design. You have the requirement. Let's go to the coding, and let's make sure that the files are getting flowed in across all the environments, sorry, or across all the different locations. So I have two services. One is the file upload service and the file consumer service. So this, as you can see, the name suggests this is the producer, right? And this guy is the consumer, right? So which will go to the each and every code, but I'll show a glimpse of it, how it works. So this is my Docker file. This Docker file, essentially it has the Zookeeper and the Kafka. And once you start using this, you have to make sure that you have this Docker desktop in your system. So just ensure that this is up and running. In my last all my videos I have shown how it works. It's very simple. You can go to Google and you can search for Docker desktop. It'll be up, and you can just install it next for the Windows, right? And then you can install it. Should be very straightforward. And this is my Docker compose file. I will put this file in my Git repo. You can take this file and then make sure that you can upload this, so you can start the Docker image in your local. So in this, right, I have this image. I'm using this image. In this, you have to make sure that these two things, right, has to be the same. These two, Zookeeper and Kafka, and I'm using these two ports. And then this is my Zookeeper. So this Zookeeper, as you can see here, it is already, I'm just making sure first Zookeeper it runs, and then the Kafka, right? Otherwise it will not work, right? And I'm already creating this topic having one partition, one replication factor. I hope you are very similar with this partitions and the replication factor. Now this create topic, you can use your coding also to do it, but this is more convenient, so I did that, right? Now we can run this Docker file. So you can go to the terminals in my IntelliJ, and you can write docker compose docker docker compose -f file, make it up. So it will take a time, so I'll just pause this video. All right, I think this is it ran successfully. What you can do, you can just do a confirmation from the terminal once again, docker ps. So you can see I have both Kafka and Zookeeper up and running, these two guys on this terminal. Now we can start our application. So just use this application. I'll show the application first how it works, right, and then we'll go to the coding, right. I'll just make sure that this guy also it runs the consumer. Okay, meanwhile it's working, right. So let me go to offset. I hope you know about the offset. It's basically you can see the messages. It's very convenient to see. It's a kind of UI where you can see each of the messages to agree with this. So you can download this from again from Google, and it's free of cost. So as you know, right, I'm running this on 9092. Just do a ping. Okay, so this guy is successful. Okay, so now just click on, you can see here, right, in the connect. Just connect this, and as you can see here, I have broker topics. Will not go to the broker because we already know this 9092 it will run, right. Now the topics I have already this topic which just now I've shown you to the compose file, and if you see, right, I can see the data, and it just go and make string, yeah, partition. So we know, right, it's only one partition, so it's 0. The data looks like there is no data, which is okay. And there are consumers. You can see the consumers. I'll show you the consumers also in some time, right. It's there in the coding. Okay, so since the application is running, we'll just test it out once. All right, my application is running on 8082, and there are some bunch of JavaScripts, and then index HTML. We'll go to the code, don't worry. And then I just go 8082, and I'll upload a file. For now, what I'll do, I'll upload my last video, Netflix video, which is there is almost system design. Um, you know, Let me put the smaller one. Oh, it went too fast. Okay. Um, let's take one bigger one so that it will be. So it looks like okay. That's okay. Now I can for the bigger file. It's taking like this. Yeah, so this is what I was talking about in the system design. Once you upload this, it should show what is the progress file. The previous file, it was quite small. That's the reason it was so fast we couldn't even guess what happened. So this file is quite big, and you can see this video which I have uploaded in my YouTube channel. The previous video which I have uploaded, the system design for the free and the custom Netflix customers. So that video I have uploaded. It's taking time, and what you can do, you can go over here and let's see if any data is coming or not. So you can see here, right, it's keep on coming the data. So the data is coming, so it is basically it's producing the data, right. And these are the number of chunks you can see here, right? These are the chunks, and no, let's see if it is 95. Okay, 96, 97, 98. All right, so 100% is done, which ensures that the file completion is done, right. And so this is what it got created. These are the chunks it got created, and if you open each of the, i, I hope I will be able to copy this. Okay, so my system got hang. All right, so let's do one thing. Let's take one of the payload, right. I'll just show you what it is inside. So I'll just copy this, and then I'll go to my notepad and paste it. So what you can see over here, right, it's a bunch of all these data bytes, which will anyways will combine it. And if you go down, right, so you can see here, is this the final chunk? It is the signal is false, and is the file is corrupted. I don't know why it is true, but we have to check. All right. Um, so okay, file upload verification is done. Very good. Okay, so let's go to the code. We'll go over the code, and then I'll explain each and everything. So the browser which just now you have seen, right, the browser is so I'm using Time Leaf. So if you are from the Java background, you will understand what is time leap. So that is, in the Spring itself we can put some of the HTML files, and we can put some static JS files, and we can run it very easily. It's very convenient. So if I go to my build.gradle file, so there are some couple of dependencies I have added, which ensures that my time leap is working fine. So if I show you the dependencies, I have Kafka dependency, which is I'm using as a producer. So this file upload, it will work as a producer. And then I'm using Spring Web because I have to expose some of the APIs, and Timely because I'm using as a HTML. So each of the HTML, it will first it will call the JavaScript, which will basically I've shown as a client, which will split the files, and then each of the files it will call the APIs, right? I hope you can still remember those steps. All right. So this is the client. So I'm talking about this client, right? So this client is nothing but my HTML page. This HTML page, right? It doesn't have any fancy thing. So what I'm doing from here, I'm just calling one method. Sorry, one JavaScript. I'm just calling this Java upload.js, right? So this upload.js. So this is the event on change. It will call this event upload file. Now this upload file, it has it calculates the hash, because as you remember, right, we have to make sure that the file is corrupted, not corrupted, all these things you have to calculate. And then there is a progress bar which is showing over here, and then I have to chunk it. So you can see here there is some chunking logic I have given. We can change this chunking logic based upon our requirement. I am doing on the 1 MB most probably, as far as I can see. And then I'm putting into the file into some date and all this calculation I'm putting, right? And I'm calling the API. So in the API, right, I'm just so there are a bunch of values I'm putting, because I have to know what is the chunk ID, what is the file name, and the file ID, all these things I'm doing. And these are the anyways, these are created by the this JavaScript itself, right? And if I go a little bit down, I'm just calling the upload API from here. All right, so this is my API I'm calling, and this API has this payload. Now this payload, it will change based on the the last response, because I have to tell what is my chunk number, and then I have to tell is this the last message, right? And then there is a on alert also, I'm telling hey, this is verified and all these things. All right, so I just make sure that my code is running. Sorry, I have written already my code, so that I'll not waste time in writing the code. Otherwise the video will become too long. Okay, so this is my API, right? So this API, it has this attributes. So the file, which is in the byte formats, and this file, this is the chunk ID, all these attributes actually, and I think it has to tell me is this the last chunk, right? Now if I go down a little bit, so I'm calling the API, which will ultimately send the data into the Kafka. Yeah, so each and every time I'm pushing the message, right, with the data, and there is one more if condition is there, based on the if it is a final chunk, right, and then immediately it will return it. So this condition you can check, based on that you can change your logic, because it has to tell what is my last message, is it corrupted, so that corruption merge logic, right? And this is the hash value calculator. So everything I have written over here, so it will ensure that the file is not corrupted, right? So let's go to the producer ones. So this is my producer. I'm using Kafka template. So in the Kafka template, I'm so if you see my Kafka template configurations, I'll go to my configurations ones. So in the configuration, the same thing I have put whatever the server, serializer, everything I have put JSON serializer, right? And this is the bean I'm creating, right? And this bean, so if you see, right, I'm auto adding it. So this bean is already available, right? So this is my bean, right? So and if I go to my So this is the bean I'm using it, and the same bean I'm just using it to send the messages, and this is my topic, right? Now let's go to the consumer. So in the consumer, I have created in one service, I think the five consumers I have created. So as you can see here, right? So I have created five consumers. I'll just go here once. I'll just show you. So you can see here, Asia, Europe, and all these guys will get the messages. Asia, Europe, North America, South Africa, all these things I have created, which is showing over here because I have created quite a few listeners. These are the group IDs, which is showing over there, Europe and North America, all these things it is showing over there, same things. So each of the guys it will get the messages because they have the same topic name. Group names are different. That is the property of Kafka, how it works internally. And then it has a file processing logic. Basically, it will merge the files based on the if else add condition. Right? If it is the last file, the file is not corrupted. All these things I have written the code over here, right? And then it will merge the file if it is the final one. So this is how it works internally, the entire system design and the ultimate flow. I hope you got it. And if you can see my logs, in the logs also I'm printing the same thing, messages by each of the continents, right? So you might be thinking why it is getting repeated multiple times, as because these are coming as a chunks, right? And the chunks I'm just combining it at the end based on the signal, whether it is the file is corrupted or not, and the delete we have to delete or not, right? Okay, I hope you are very much clear with this topic. Let me know how it feels about the topic, and if you have any questions or if you want me to give some suggestion where I can improve, please do let me know in the comments. Thank you so much.